Okay, so in this lesson, we're going to build or write polynomials using zeros, or given that you're told that a number is a zero. Before we can do that, though, let's remind ourselves about the factor theorem. And so remember, the factor theorem said this: for a polynomial p of x, if p of c is equal to 0, then x minus c is a factor of p of x. And the same thing if we go the other way. If x minus c is a factor of a polynomial, then p of c must be 0. Now, I want to remind you, based on our previous lessons, that if p of c is equal to 0, so if I have this polynomial that's equal to 0 for a value of c, remember that c is called a 0. So note that c is called a 0 of the polynomial p of x. Okay? All right, so let's look at some examples. Let's start off with some examples. Example 1. Okay, so let's say example 1 said this. Example 1, suppose you were told that suppose x equal 3 is a 0 of, let's say, f of x. Okay, so if x equal 3 is a 0 of f of x, then here's the question: what must be a factor of f of x? What must be a factor of f of x? So if you were to factor f of x, whatever f of x is, what must be one of the factors? Well, according to the factor theorem, if x equal 3 is a 0, then x minus 3 must be a factor. So the answer, x minus 3 must be a factor. Okay? Example 2. All right, so this time suppose x equal -2 and x equal 5 are zeros of f of x. Okay, what must be factors of f of x? What must be factors of f of x? So the answer, according to the factor theorem, if x equal -2 is a 0, then remember x plus 2 must be a factor. Okay? Because remember, x equals c, right? So you'd say x minus a -2, so c is -2. And then over here, if x equal 5 is a 0, then x minus 5 must be a factor. All right. So I want you to notice, and this is going to help some of you as we move through the lesson. If I bring the -2 over, you can get x plus 2, right? Over here, x minus 5, you bring the 5 over. That's where these are coming from. Okay? All right, example 3. Now this is where you got to be careful. Okay, listen carefully as I go through this. All right. If x equal 2/3, this time we have a fraction that's a 0. X equal 2/3 is a 0 of g of x, let's say, of this polynomial function. Then what must be a factor of g of x? What must be a factor of g of x? So if x equal 2/3 is a 0, right? So then we know x minus 2/3 must be a factor. Correct? Just like we did before. X equal 3, we wrote it as x minus 3 is a factor. X equal -2, we wrote it as x plus 2. X equal 5, x minus 5. But here's what I want you to remember. If we go back to a previous lesson, and let me see if I can quickly get to it. If we go back to a previous lesson, remember this one right here? X equal 1/3 was a 0, but then our factor was 3x minus 1. You see this? We didn't write as x minus 1/3, did we? So what I want you to remember is this now. So we don't prefer to write the answer, the factor is x minus 2/3. Okay? What I want you to do is this. I want you to multiply. Think of it like this. Remember when we got this 0 right here, we said each of those factors equal to 0, okay? Because that we're finding zeros. So we found the 0 by setting this equal to 0. So what I want you to do is this. Set this equal to 0, and then multiply both sides by the LCD. So clear the fractions. So we're going to multiply both sides by the LCD. Okay, so times 3 times 3. And then distribute. And so I get 3x minus, and then 3 times 2/3 is just 2, equal 0. So here's your other factor. So what we prefer to say is this. If x equal 2/3 is a 0 of g of x, then 3x minus 2 is a factor. Okay, so the factor is 3x minus 2. All right, so that's the one I want you to write. Okay? So let's look at another one with a fraction in it. Example 4. If x equal 4/5 is a 0 of g of x, then what would be a factor? Don't say x minus 4/5 is the factor. Okay, I want you to clear the fractions. So you would say x minus 4/5. Well, you would eventually do it first. Okay, just write this first. Okay, then multiply both sides by 5, just like this. Okay, and then distribute. So I get 5x. 5 times a negative 4/5 is a negative 4, equal, and then 0 times 5 is 0, and so that's your factor right here. So if x equal 4/5 is a 0, then 5x minus 4 is a factor of g of x. All right, example 5. All right, example 5. If x equal negative 3/4 is a 0 of h of x, then what will be a factor? Then a factor is, all right, so remember what you would do. You would write this as an equation, so you'd say x plus 3/4 equals 0. Then you multiply both sides by the LCD, which is 4, so you're going to clear the fractions. Okay, so multiply both sides by 4, then distribute and clear the fractions, so we get 4x. 4 times 3/4 is just 3, plus 3, equal, and then 0 times 4 is 0. So this is your factor. So you would say, then a factor is 4x plus 3. That's your answer. Okay? Example 6. All right, now listen carefully to this part. If x equal 2 and x equal 3/7 are zeros to f of x, then the factors must include what factors? Okay, so we know that 2 zeros of f of x are these two. All right, so then your answer, this one's easy. So if x equal 2 is a 0, then x minus 2 is a factor. That one's easy. It's a factor. Over here, If x equals 3/7 is a 0, don't say x minus 3/7. I want you to clear the fraction. So for that one, you would say x minus 3/7 equals 0, then multiply both sides by 7, and then distribute, you get 7x minus 3 equals 0. So there's your other factor. This right here is your other factor. So answer, x minus 2 is a factor, and 7x minus 3 is a factor. All right, kind of makes sense, because if this is a factor and you set it equal to 0, you're going to get x equals 3/7, right? That's what you would get. Okay. All right, so now we're going to change gears a little bit. So listen to the next example. So this will be example 7. Example 7. Okay, so write a polynomial function in which the only zeros are 2 and -4. 2 and -4. Okay, so write a polynomial function in which the only zeros are 2 and -4. Okay, so here's going to be your work. So you're going to say, well, if 2 is a 0, then a factor would be x minus 2. So the factors are x minus 2 and x plus 4. And always check. So if 2 is a 0, then a factor is x minus 2. So if I set that equal to 0, I'm going to get 2. If I set this equal to 0, I'm going to get -4. So you can always check. Okay? But remember, when you're writing a polynomial function and those are your factors, you're going to write as a product. So you're going to say the answer, f of x equal x minus 2 times x plus 4. And then let's go ahead and distribute this. So if I distribute, I'm going to get x squared. The outer is 4x. The inner is -2x. So you get positive 2x. And then -2 times 4 is a -8. All right. Now, it did not matter which one. You can leave it like this or like this. Does not matter. Okay. I would just go ahead and leave it like this. So you wrote a polynomial function. You're done. But here's what I want you to remember. Do you remember in our previous lesson when we talked about a review, when we reviewed the previous lesson, we saw that this function has those zeros and this function had the same zeros, didn't it? What was the only difference? The only difference was that coefficient. It did not matter what that coefficient out in front was. As long as you had the same factors in terms of the factors with the variables, it did not matter what that coefficient is. You would have the same zeros. So the point's this. Someone else could have said another answer could have been this. F of x equal 3 times x minus 2 times x plus 4. That could be another answer. Someone else could have said, and I'm going to go ahead and change the notation here to g of x. Someone else could have said g of x is equal to 1/2 times x minus 2 times x plus 4. Do you see there's an infinite number of ways to indicate the polynomial function? As long as you have those two factors listed, remember those are the only zeros, right? So you can't put any other factor with a variable. The only thing you can do is just change the coefficient. That's all you can do. All right. So you have, if you set that equal to 0, you're going to get 2. If you set this equal to 0, you're going to get -4 in every case. So there's an infinite, and so on. So there's an infinite number of answers. Okay. All right. Let's look at the next example. Example 6. I'm sorry. Example 8. Okay, example 8, write a polynomial function h of x. So this time I'm telling you what notation to use, in which the zeros are -2, -7, and 5. So this time you have 3 zeros. Okay? So your work, you're going to say, well, if -2 is a 0, then x plus 2 is a factor. If x minus 7 is a 0, then x plus 7 is a factor. If x equals 5 is a 0, then x minus 5 is a factor. So your answer, you're going to say h of x will be the product of these factors. X plus 2, x plus 7, x minus 5. And it does not matter in the order you write this. You could have said x minus 5 in front or x plus 7 in front, does not matter. Okay? Now don't multiply this out, because if you multiply it out and you get the wrong, and there's one or more terms incorrect, I'm going to have to take points away. So leave it like this. Leave it like this. Don't multiply it out. I only multiplied it out here just to show you that if it's two binomials, and it's easy to do, and it did not matter which way you wrote it. Now, remember, there's an infinite number of answers, right? All you have to do is just change the coefficient. This coefficient's 1. Someone else could have said this. Someone else could have said h of x is negative 2 times x plus 2 times x plus 7 times x minus 5. So you get the same zeros. The functions are different. When you graph this, they're going to look different, but they're going to cross the x-axis at the same place. So remember, zeros are the same thing as your x-intercepts. So when you graph these, at some point, you're going to get the x-intercepts will be the same. The graphs will look different, but it's going to cross the x-axis at these 3 points. Okay? Someone else could have said this. Could have said 4/3 times x plus 2 times x plus 7 times x minus 5, etc. So there's an infinite number of answers. As long as you all have the 3 same factors, the coefficient does not matter. Okay? All right, so that's example 8. All right, let's look at number 9. So write a polynomial function in which the zeros are x equals 4 with multiplicity 2. Now what that multiplicity means, remember, we talked about that very briefly at some point previously, but what that means is that this occurs twice. So the multiplicity means this occurs twice. So x equals 4 occurred twice as a solution. Okay, that's what that means. So what this means, so this is your idea in terms of work. What this means is that, so if x equals 4 is a 0, then x minus 4 is a factor, right? So multiplicity 2 means that x equals 4 is a factor twice. That's what that means. X equals 4, x minus 4 is a factor twice. Okay? So your answer, and I didn't indicate what notation to use, so I'm just going to call it f of x. So you're going to say f of x is going to equal x minus 4 times x minus 4. Or you could have written it as x minus 4 squared. Okay? So notice if I said each of those equal to 0, 4 occurs how many times? X equals 4 occurs how many times? X equals 4 occurs twice. So that's what we mean by multiplicity. Okay? Someone else could have said, now again, I did not indicate the notation to use, so you could have said g of x is equal to negative x minus 4 times x minus 4. Or you could have said g of x was equal to 2/3 times x minus 4 times x minus 4. As long as you all have x minus 4 twice like this, it does not matter what the coefficient is. You'll get the same zeros. The graphs will look different. The graphs will look different, but they will cross the x-axis at the same place. Okay, that was example 9. Let's look at example 10. All right, let's look at number 10. So remember, build, write is the same thing. So build a polynomial function, and let's call this h of x. H of x, in which the zeros are, now be careful, let's read it carefully, in which the zeros are 3 with multiplicity 2, negative 5. Now, if it doesn't indicate the multiplicity, then negative 5 only occurs once. Negative 5 is a 0 once. So that's why you saw when we did these, if I can get back to it, see here, the zeros are 2 and negative 4. So 2, the multiplicity is only 1. It only occurred once. Here, negative 4 only occurred once. Okay? So 3 occurs as a 0 twice. -5 occurs as a 0 once. 6 occurs as a 0 how many times? 3. And so here's how you write your answer. So your answer, you're going to say h of x is going to equal, all right, if 3 is a 0, remember that means x minus 3 is a factor. How many times does it occur? Twice. So just put it as squared. Okay? X minus 5 is a 0. How many times does it occur? It occurred only once. So you're going to say x plus 5 is a factor. 6 is a 0, so that means x minus 6 is a factor. How many times does it occur? 3. So just say x minus 6 cubed, and there's your answer. Now remember, there's an infinite number of ways of writing the answer, because you can always, remember, any polynomial that has these factors and these multiplicities, according to this, will have the same zeros. It does not matter, though, what the coefficient is. So if you want to say equals 3 times x minus 3 squared times x plus 5 times x minus 6 cubed, does not matter. And by the way, you could have put x plus 5 last, you could have put x plus 5 in front, does not matter. But always put the coefficient in front. Someone else could have said h of x equal -7 times x, I'm going to change these orders, x minus 6 cubed times x minus 3 squared times x plus 5. Does not matter, right? So there's an infinite number of answers as long as you have these factors raised to the correct exponent. All right, so that was example 10. Let's look at example 11. See, it's not that difficult. It's fairly easy to deal with. All right, let's look at example 11. So build a polynomial function f of x in which the zeros are, and there are 4 zeros, 1, 2, 3, 4. -2, though, let me rephrase it. There are 4 distinct zeros. -2 occurred twice, and 4 occurs 3 times, right? Notice -3, there's no multiplicity listed with it, so assume that -3 only occurs once. And assume 7 only occurs once. All right, it's a 0 only once. Okay, so the answer, let's just do it in the order in which it's written. So -2 is a 0, then that means, and remember we've got to say f of x equal. So what most students are going to write is they're just going to write what they see here, and they're going to leave this as coefficient 1. So if -2 is a 0, then x plus 2 is a factor. How many times did -2 occur? Twice. You're going to say squared. Okay. If x minus 3 is a 0, then what's a factor? X plus 3. Times. If 4 is a 0, then x minus 4 is a factor. And then how many times it occurred? 3. So your exponent's 3. And then 7 is a 0. It only occurs once. So you're going to say x minus 7. So there's your answer. Again, someone else could have said f of x equals, and remember you would have to have the same set of factors raised to the same exponents, but it does not matter what your coefficient is. So someone else could have said -6 if they wanted to. Okay? And so on. All right. I'm just going to put etc. because there's an infinite number of answers. Let's do one more. Let's look at example 12. Example 12. All right. Now, so example 12 is just like all the other examples, except notice that we have a fraction here. And remember, I want you to rewrite this in a certain way. So we get to it. Remember what we said. Okay. So our zeros are -2. Notice it doesn't say multiplicity, so it's only going to occur once. 5 has multiplicity 2, and 2/3 only occurs once. Okay? And I want you to use h of x. So we're going to say answer. You're going to say h of x is going to equal, all right, if -2 is a 0, then x plus 2 is a factor, and it occurs only once. If 5 is a 0, then x minus 5 is a factor, and it occurred twice. So put that as x plus 5 squared. Now, be careful here. Okay, be careful. So don't say x minus 2/3. Don't say x minus 2/3, because remember, I want you to say this. So if x equal 2/3 is a 0, right, then that means x minus 2/3 is a factor, but clear the fractions. So what we did to do that, remember, if it's a 0, then we set it equal to 0, and then we multiply both sides by 3, and then distribute. So we get 3x, and then 3 times 2/3 is 2, so 3x minus 2 equals 0. 0 times 3 is 0, and that's what we use as our factor. Okay, so 3x minus 2. So if 2/3 is a 0, then 3x minus 2 is a factor. Okay? All right. Now remember, for the ones with the exponents other than 1, you could have listed it twice. So this you could have said x plus 2 times x plus 2, and this you could have listed 3 times. But it is easier, it is better to leave it with the exponent. All right. Now someone else could have said this. Someone else could have said 4 times x plus 2 times x minus 5 squared times 3x minus 2. Okay? All right. Let's do one more with a fraction just so you can quickly write it the way that I want you to write it. Okay, let's look at one more example, 13. Okay, so build a polynomial function f of x in which the zeros are 3/4 with multiplicity 2 and -3 with multiplicity 2. Okay, so remember the 3/4. Let's talk about the 3/4, and let's do it just like we did this one. So if x equals 3/4 is a 0, just do this. Okay, bring the 3/4 over. I get x minus 3/4 equals 0, right? Then we'll multiply both sides by 4 to clear the fractions. The LCD is 4. Then distribute. I'm going to get 4 times x is 4x, and then 4 times a -3/4 is a -3 equal 0. And that's the factor you're going to use. So 4x minus 3. So your answer, you're going to say f of x is going to equal 4x minus 3, and it has multiplicity 2. Kind of makes sense, right? Because if you set that equal to 0, don't you get 3/4? Okay? And then the other one is if -3 is a 0, then x plus 3 is a 0, and it has multiplicity 2 as well. All right? So that's the answer that most students will write. But remember, you have an infinite number of answers here as long as the factors are the same with the exponents, correct? With the exponents being the correct exponents, and you could change the coefficients to whatever you want. So someone else could have said f of x equal, let's say 4 times 4x minus 3 squared times x plus 3 squared. All right. Okay, so that is the lesson on building polynomials using zeros.